Hey everyone, welcome back. We have already covered vector, DQ, stack and queue. Today we are going to cover one of the containers in STL, priority queue. Priority queue can be used for different operations like maxHeap and minHeap, and also we can create our own custom. Okay, so we can use priority queue for maxHeap, minHeap and custom comparators. Means maxHeap means it always keeps the max element at the top. Means if we have a 10, 9, 8, 7, 2, if we remove 10, the 9 will at the top. If you insert 11, then 11 will be at the top. So maxHeap will keep your maximum element at the top. Similarly, minHeap will always keep your minimum element at the top. Okay, this is a minHeap and this is a maxHeap. By default, priority queue has a maxHeap only. MinHeap can be achieved using priority queue itself and other methods, and we can also use custom comparators to arrange our elements in the priority queue according to our criteria. So basically priority queue is just like a normal queue. But instead of FIFO order, the largest or smallest always stays at the top. FIFO is first in first out, right, in a queue, but in priority queue your largest or smallest will be at the top. By default priority queue has max heap, means by default all the elements are at the top. Min heap can be achieved by some alterations in the priority queue itself. Similarly, if we want to arrange element in the priority queue according to our criteria, we can also use custom comparators. Basically these are custom functions we are going to build to compare the values in the priority queues. Let's look how we are going to use maxHeap. First let's declare our priority queue, then priority queue underscore queue. Okay, then our data type int, then our variable name. To add element in the priority queue we can use push itself, then again, and if we want to print top element in the priority queue we can use pq dot top, right? These are similar to the tag. Now this is for the max heap, means we have a priority queue. We first inserted a 10, so 10 should be here, then we inserted a 20, then 20 will be here. Let's insert one more value, pq dot push of 3. So I inserted a 3, then 3 will come at the end and our priority queue will become 20, 10, 3, because top element will be at the top. Now this is for the max heap. Now if we want to use min heap, so we will write priority queue, then our data types, then comma, then we write vector int, then greater int. Okay, so we have here three arguments, we can say int, then our vector, then there is a greater. These will internally sort your data in ascending order, means your smallest element will be at the top. So let's see, pq dot push, if I push a 20, pq dot push, I push a 20, then pq dot push of 30. Okay, let's see, this is our container. Initially I pushed 20, then I pushed 10, then push 20, then internally it will change and 10 will at the top, then I pushed again 30, then 30 will come at the end, so our smallest element will be at the top. Okay, this is for the max heap and this is for the min heap. Let's also look here, you can only pushing a single value. Let's say if you want to push a value in a pairs, right? So there is another data structure which is we called a pair is not usable individually. In most of the case pair is used with other containers. So let's declare it priority queue, then we have a pair, then we have a int of int. So this time our data will be stored in this form. Okay, there we have two values in a single data. So priority queue, then pair contains two values. Okay, so most of the time pairs is used with other containers. Similarly you can use with the dq, or you can use with the queue and stack also. So let's see how we are going to insert or push the value in the priority. So we will write pq dot push, Then now we cannot push a single value, we have to push a two value, so we will use curly brackets, then 10 comma 2. So single, we can say single data containing two values at a time. Okay, similarly we can use pq dot push, then 5 comma 4, pq dot push 20 comma 1. So these are the value we pushed. Okay, now how we are going to decide which element will be at the top? So it will sort your data according to the first value. Okay, so at the bottom it will be 5 4, then 10 2, then 21. That's how it is going to sort your data. If you want to print top value, you will write cout pq dot top. Now you cannot print both the value at a time, you have to access one by one. So we are accessing p dot q dot top value, and this one is first and this one is second, so we will write pq dot top dot first, so it will print 20. Okay, so similarly we can also pq dot pop, right? It will remove our first value or top value. Now these are basic operations we have seen in all our containers which we have covered till now. Let's look at the custom comparators, because this is very important in a programming, because not every time you have to arrange your data in ascending or descending. Sometimes you want to arrange your data based on your needs, right? Let's take this case here. Here we are sorting our data with the first value. Okay, what about the second value? The second value is not sorted, right? Let's say if I want to sort my data based on second value, but priority queue only allowing to sort with the first value, so we want to with the second value, so we have to write a custom comparator. Okay, so to write a custom comparator, first we will write priority queue, then let's take a pair of int, then we will have a vector of pair of int, then we will write our compare, then pq priority queue, then pair, then comma, then vector which also containing pair, then comma compare. This compare is our custom comparator. Okay, now we have to write this custom compare, so we will use struct keyword available in the C++ to create our custom comparator. So we first write struct, then we will write compare curly bracket, then bool, because it will return true or false if we want to compare two values. If we comparing two values, it will return either true or false. So bool, then we will write operator, then pair int a and pair of int of b. So basically it is taking one pair, it is taking another pair, means we have something 5 comma 4 and we have something 10 comma 2, right? This is one pair, this is second pair, so it will be comparing between these two pair. Then it will return a dot second comma b dot second, right? Means let's say we have a pair 1 10 comma 2, then we have a pair 5 comma 4. Now this is assigned a and this is assigned b. We are comparing a dot second. A dot second is 2, b dot second is 4. Is 2 greater than 4? No, so it will return false. False means we don't have to change anything, because what we want here, we want our a second should be false, so we don't have to change anything. That means we are sorting according to the second value, and we are also keeping the min heap, means the smallest will be at the top according to the second value. Similarly we also can use here less than sign, then it will become a maxHeap. Okay, let's run these examples in the VS code so you will be able to understand. Okay, so I'm going to use the same file stl.cpp. Let's remove this. Let's declare our priority queue, then int of pq. Okay, then pq dot push, let's add 1, let's make a copy, and 5 and 6. Okay, now let's print cout pq dot top. Let's run it. Here you can see it is printing me the 6 value which is at the top. Let's print all the values. Priority queue is similar to the stack and queue dequeue, so you cannot iterate with the standard methods like for loop, so we have to use while with the pop. So we will write while pq not empty, we will print our pq dot top, then spaces, then pq dot pop. let's print it. Here you can see it is printing me 651. Okay, now let's use minHeap. So we are going to change in this priority queue itself. So after int you have to write back comma, then vector of int and comma greater of int. Okay, now let's run it. Now it is printing me the 156. So our priority queue changed from maxheap to the minheap. Now let's use our pair also. So let me clear it. We will write pair int comma int. Now this time here you can see it is giving me the error because it is asking me a pair. Okay, we cannot insert a single value. So let's take our example. Okay, 10 comma 2, then 5 comma 4, then 20 comma 1. Okay, now we have to fix it also here. pq dot top dot first. Let's print pq dot top dot second also. Okay, let's change the line and run it. Here you can see it is printing me 20 10 5, and it is sorting according to the first value. Okay, now let's create a custom comparator which will sort according to the second value. First let's create a custom comparator struct, and we will write compare here. Then here we will write our bool operator, which is our pair of int. This is our first pair, this is our second pair. Okay, I made a mistake here. Then it will return a dot second, b dot second. Okay, now let's use our compare. We have to also use vector of pair int. Right now it is giving me the error for, okay, here we have to use comma. Now let's run it. Now here you can see it is similar to the previous one, right? Because we are sorting according to the second value and it is a mini. Now let's make it a maxi. So let's run it. Here you can see it is sorting according to the second value and also keeping the maxi itself. So that's how we can use custom comparators also, and rest of them are same, similar to the post, top, pop, size and empty. Similarly we can traverse the priority queues similar to the stack and queues. Okay, that's it for the priority queues. Thank you everyone, have a nice day.